Well, hey class, thanks for joining me. I'm going to be going through the study team test that we took today in class. The plan is on Friday, you'll be taking the individual test. So I'm going to post this video tonight and get these back to you so that you can take a look at them uh, before you show up to class on Friday. So the very first problem we have here asks us to um, compare two salary situations and decide when you will potentially have a larger salary than your cousin. So after college, you get a job with a starting salary of $35,500. Your first day on the job is January 1st of 2030. You have a cousin working at the same corporation, but he was hired 3 years before you. Your contract states that you will receive a pay raise each year of 7%. Suppose your cousin confesses, hey, I began with $40,000, right? They started paying me more than you, and my contract has a 5% pay raise. Make a table showing both salaries of you and your cousin for the next 5 years. Now, I'm going to extend this table a little bit. I'm going to go beyond 5 years. The reason why I'm going to do that is I do not have one of my TI-83 calculators. I've got this TI-30XS, which limits me to one table. So I'm going to go with this and kind of look at both. And probably before I do the table, down here it says write a formula you could use to determine your salary giving any number of years and your cousin's salary given any number of years. And then what would an input of -3 mean? Okay, so I'm going to write some formulas here first. So someone asked during class, like, well, does it have to be a single formula or could I write two different formulas? Yeah, you can write two different formulas, or you could write a formula where you're looking at the difference between the salaries as well. I'm going to go ahead and start and do two formulas. So both of them I'm going to call, actually for you, I'm going to call your function f of x. And you are starting with a salary of $35,500. And every year it's growing by 7%, right? So our multiplier is 1.07, and we're going to be raising that to the x power. So after x number of years, right, this will predict, well, not predict, it'll tell you exactly what your salary is. Now, of course, contracts change. None of this stays in place forever, and you can renegotiate things after time, but this is what we're working with. So in this first column, I'm going to say these are x, these are years. I'm going to say this first one is f of x, which represents your salary. And I'm going to go ahead and use the name g of x to represent your cousin's salary. And your cousin starts out with a pay package of $40,000 a year. And he is earning a 5% pay raise each year that goes by. And again, this is g of x. Now, a little thing that's interesting here. Your cousin has been working at this place longer than you, right? So by the time you're there, he would have already had three pay raises. So certainly he started with $40,000, right? But he's not at $40,000 when you're at $35,500. So to adjust that, what I'm going to do is I'm just going to come in and say, look, I want to add 5, not 5, 3 years. I'm going to add 3 to your cousin's salary. And I don't think I'm going to use the table function on my calculator. I think I'm just going to enter the numbers. So I'm going to enter 35,500, enter, and I'm going to go times 1.07. So 35,500, 1.07. And I'm starting to get numbers here. So when you start, and then 1 year, 2 years, 3 years, 4, 5, 6, 7, 8, 9, 10, 11. I'll stop at 12. So you started at 35,500, and then you went at year one to 37,985, and then the next year you're at $40,643.95. And then the next year you are at $43,000 rather, $489, and I'm going to round that to 3 cents. It's 0.0265. And then the next year you make it to 46,000. This is hard to write these numbers. $46,533.26. Next year you go to $49,790.59. And then we're at $53,275.93. I'm rounding to the nearest penny each time. Year 7 is $57,005.24. Year 8 is $60,995.61. Year 9 is at $65,265.30. Next year is, gosh, I'm guessing, okay, that's a mistake. $69,833.87. I'm kind of losing track of where I'm at here. So I'm like, what? So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 11 goes to 9, 10. 11 goes to $74,722.24. And the last year that I'm going to record on this table, and the table did not ask for this. This is ridiculous. It's $79,952.80. All right. And you know what? To be honest, I'm going to stop at 5 years for your cousin, because that's just torturous, right? I'm only supposed to go for 5 years for the table. So your cousin, now, okay, so I got to be careful here. Cousin starts at $40,000 to enter, and then times 1.05. The problem is your cousin gets 1, 2, 3 years before you even show up. So at year 3, which is your 0, your cousin's making $46,305 and no change. Next year, it's at next year is at $48,620.25, and then it goes to $51,051.26. Next year is at $53,603.82. Next year is $56,284.02, if I round correctly. Next year, $59,000. 59,098.21. So, yikes. I believe the gap is getting smaller, right? But I don't think it's going to get small enough in 12 years. So here's what I'm going to do. I am going to write a new function, right? And here's what I'm going to do. I'm going to take your cousin's salary, which is g of x, and I'm going to subtract from that your salary, which is f of x. And what I want to know is, initially that's going to be positive because your cousin's making more money. But at some year, right, at some year down the road, it's going to get to where you are making more money than your cousin. And the moment that happens, this function is going to produce a negative number, right? So on my TI 30X plus the classroom calculators that we have, I'm hitting table, and I'm clearing my current table, and I'm going to enter the following. I'm going to enter $40,000 times 1.05 raised to the power of, and I'm going to have to stay up in that exponent. I want to go x plus 3 extra years. leave the exponent. Okay, so that's G of X minus your salary. So from that, I'm going $35,500 raised to the power. Oh, no, not raised to the power yet. Don't get crazy. Times 1.07 to the power of X. So essentially what I've done is using the table function on this calculator, I've literally just typed this function. I've typed this, and then I've subtracted this from it, right? So it literally looks, it's just, it's the 40,000 times 1.05x. I don't have the ability to show this calculator screen on this recorder, so sorry about that. But what I need to do now is I'm just going to go ahead and ask it to generate a table of values. So I'm pressing enter. I'm going to ask it to start at year 0 and step by 1. And when I do that, what I get, first of all, is that the very first year that you both work at the company, the difference in your salary is $10,805. The next year it's $10,635, and then $10,407. So I can see that the difference between these salaries is decreasing. By the time I get to year 6, it's $8,150. All right, I'm going to keep going. Year 10, 11, 12, 13. Okay, this is interesting. So at year 14, your cousin is making $142 more than you are. 14 years at the same company, cousin's still making $142.77 more than you. But the very next year, right, year 15, because this becomes a negative number, right? It's now on my calculator, it says negative 1,680. You are now making $1,680 more than your cousin. So at that point, at year 15, you're writing more. So I would say, look, a combined formula given f of x and g of x would look like this, right? G of x minus f of x. And if this is producing, I'll just put a little note here. If this is a positive number, I can do better than that, right? I can say something more mathematical. I can say if this is greater than 0, then your cousin makes more. But if this becomes a number that's less than 0, right, because it's g of x minus f of x, at that point, you are making more money. And that happens at year 15, right? Year 15. All right. Now, that I think was all. It says, how long will it take before your salary exceeds your cousin's salary? 15 years. We got that. 15 years. I'll put it here too. 15 years. And I wasn't thinking I was going to write a formula, but because I defined f of x and g of x differently, right? F of x is your salary and g of x is your cousin's salary. It's pretty easy to go ahead and write this, right? G of x, your cousin's salary minus yours. If that's a positive number, the cousin's making more. If it's negative, you're making more. So it's kind of easy to combine that and make one formula. So it was a little intimidating, to be honest, but I think it turns out better than I thought, and we now have a solution there. I will not comment on this part. This was extra credit. I'll be looking at your scores or your test individually and see how that works out.